Hello everybody, this is the notes for Advanced Geometry, section 5.6. This is the last section for this chapter. What we just got done talking about in section 5.5 was just dealing with some inequalities, kind of defining how a triangle is formed, what you need to have for certain side lengths. That's the triangle inequality theorem, where the sum of the two shorter sides have to add up to be more than or greater than the longest side. And this is kind of an offshoot of that. It's another idea, but it relates two triangles together, not just dealing with forming one triangle, but the relationship of side lengths and angles in two different triangles. So, it is called the Hinge Theorem. Go ahead and hit pause and copy both of these things down. One is the Hinge Theorem, one's the converse, so going in the other direction. But take a second, copy those things down and try to think about them, what they mean. All right, so the Hinge theorem is that relationship between two triangles. Now, what you have to have is, in each triangle, you have two pairs of sides that are congruent to each other. So one pair of sides are congruent in one triangle and the other triangle, and then you have a second pair of sides that are congruent. What we're looking at is the angle between them, angle in those two triangles between those two congruent sides that will relate us to the third pair of sides. So, what we have here, we're looking at side AB in this triangle and side BC in this triangle. It's 3 and 6. Now, go to the triangle on the right. Side DE is 3, EF is 6. There is our two pairs of sides. All right, that's the first step in making sense of this and what to look for. You need to have those two pairs of sides that are congruent to each other. So now we're looking at the angle between them. So here we're looking at this 70.3, the angle E, and in this triangle, the first triangle on the left, we're looking at this angle here, angle B. Okay, so the Hinge theorem says if you have two pairs of sides congruent, and we do, AB, DE, BC is congruent to EF. The angle that is between those two pairs of sides, so 76.95 degrees, basically 77 degrees. When we compare that to that corresponding angle, the 70 degrees, because this angle, the 70.3 degrees, is smaller than the 77 degree angle, the opposite side should be smaller or less than the other third side. Okay, or the other way to think about it is this angle is bigger than that angle, so AC will be longer than FD, and it is. All right, doesn't matter how big, we have that setup, that Hinge theorem setup, where two pairs of sides are congruent. The angle in between those sides helps determine an inequality comparing one side, the third side, to the other third side. Okay, whichever angle is bigger, the third side of that triangle will be longer than the other third side. Kind of a simple idea, but it's there. Okay, the converse just goes in the opposite direction. So let's do some examples. Okay, if you want to try these on your own first, great, go for it, hit pause. But again, what we need is those two pairs of sides that are congruent. So looking at question number 3, we have the two sides that are given, but they're also sharing a side. All right, so now we're looking at the 36 degree angle and the 32 degree angle. It's the angles between the pairs of congruent sides. So the question is, AD, is it less than, is it greater than, or is it equal to side CD? 36 degrees is more than the 32. So that side opposite it should be longer than the side opposite the 32 degree angle. So that means AD is more than or greater than CD. So that's our answer, greater than. All right, so this is our thought process. Looking at question number 4, we have congruent side, we got our two pairs of congruent sides. So now we're concentrating on the 114 degree angle compared to the 123 degree angle. The question is asking about sides MN and side LK. Which one is less than, was MN less than or greater than or equal to LK? So we're looking at the, oops, grabbed the wrong thing, this 123 degree angle, it is more than the 114, so KL or LK should be longer than mn. So that means mn is shorter than. So there's our answer. Okay. Now, question number 6 kind of turns that around. This is the converse theorem. We have our congruent sides. The question is now asking about, is angle 1 smaller, greater than, or equal to angle 2? So we're looking at angles 1 and 2 are the angles between our congruent sides. Now we're concentrating on those third sides, 13 and 14. So the question is asking, is angle 1, is it less than, greater than, or equal to angle 2? Angle 1 is across from the smaller of the third sides. 13 is less than 14, so that means angle 1 is going to be smaller than angle 2. So our answer is less than. All right, question number 7, they're sharing a side. These two triangles are sharing a side. So if you look at those triangles carefully, those opposite sides of angles 1 and 2, they're equal. And plus, you got congruent triangles, side, side, side. So these two angles are corresponding, so they are going to be equal to each other. All right, in these next types of problems, kind of the same thing. It says use the Hinge theorem or its converse and properties of triangles to write and solve an inequality to describe a restriction on the value of x. So we need to have our congruent sides. Okay, we can see we got sides 12. There's one pair of sides, and we have a shared side. So now what we're looking at are two angles, the 2x plus 5 and our 66. So we're trying to solve an inequality. Okay, we got to set up an inequality. So we're looking for the connection between those two angles because it's the angles between our two pairs of congruent sides. And that's where the third sides come into play. 15 is more than 13. So that means the angle 66 degrees is going to be greater than the other angle of 2x plus 5. Now we got our inequality set up. All right, so to solve for x and find that restriction on the value of x, just solving an inequality. Subtract 5, divide by 2, does not change the direction of the inequality, but we get 30.5. X values must be greater than 30.5, and we really do have some other restrictions. X has got to be greater than or equal to. Well, this 2x plus 5, it's got to be a positive angle, so it's got to be greater than 0. So that means x has to be greater than a negative 5 halves. Okay, and it's not going to be 0, but, and it's not going to be, 0.1 degrees just because of the side lengths, but there are some restrictions here. This is our answer. Okay, looking at question number, I guess that's 17, the next one. Again, we got to find our two congruent sides. So the 3's are congruent, so there's one pair of congruent sides, and they share a side. So now what we got to do is concentrate on the 110 degree angle and then this one here, where I just put that red dot. Well, we don't know what it is, but we have the other two angles of the triangle. So 102 degrees plus 27 degrees, that's 129 degrees, which means this is a 51 degree angle. So now what we have is, just double checking on my math, that's 153. Yeah, good, okay. So now, to figure out the values of x, we have our angles. We know 110 is more than 51 degrees, and so what that means is for those third sides, the 3x plus 2, that's the side across from the 110 degree angle, it will be more than the x plus 3. That is the side across from the 51 degree angle. And so now we can solve for x. So going to subtract x from both sides, it gives us a 2x. I'm going to subtract 2 from both sides, that's a 1. That means x has to be more than 1/2. Do we have any other restrictions? I don't think so. There may be. Let me see what we got here. Oop, x is greater than 1/2. Oh, that's a different problem. Okay, that is our answer. Greater than 1/2. And that was our answer there, but we also had some other answers, so we're doing good. Okay. One last thing. Actually, we'll talk about this in class. Have a good night.